and welcome back. It's the 31st of July 2014 and we're looking at this sunspot numbers chart over the last 36 years. If you've been following the channel, you'll have seen this many times, and I'll have talked about it many times, but I feel some people don't quite grasp what it is they're actually looking at. And I just wanted to simplify it, because even though sometimes when I talk about this I feel it gets overlooked, the incredible trend that this in itself is predicting. What we're looking at is the last 36 years of sunspot activity. The red line represents 0 sunspots, and the black line, the diagonal line, represents a declining over those last 3 solar cycles that make up the 36 years. It predicts a trend, and sometimes it's very easy to take it for granted as to what it is predicting, but just look at it for a few seconds, guys. Over the last 36 years, a continuous decreasing in amount of sunspots, and we can see that it isn't going to be too long before that black line hits the red one if it continues. Now, the last 36 years, or the last 3 solar cycles, is indeed predicting a trend that will be the case. And we've looked into the Livingston and Penn's report, which I'll just grab up now so that we can follow what it is actually that we're looking at. A bit later on in this video, I'm going to show you some of that data that I've obtained from the Swarm mission and the ESA, or the European Space Agency website, where we look at around 300 years, 400 years of magnetic declination. Now remember, I did say that there was probably going back to merchant shipping records in order to get the magnetic deviation out, as opposed to fit it into some form of trend that we'll be looking at in that modelling system where we see the declination changing. However, I think if we look at just the recent 50 years, say from the 1950s to 2010, we get an idea of just how fast things have started to pick up, and we get an idea as to why they have actually started to change runway numbers with regards to where those headings would be. For those that don't know, those runway numbers usually have a number assigned to them, which is the heading in which the approaching aircraft must line up with. And if the magnetic declination is moving, then them numbers on board the aircraft aren't going to tally up with the numbers on the runway. So even if it's 1 degree out, there can be a large distance off the runway, or the approach to the runway, that commercial and non-commercial pilots use as a form of navigation, or at least an aligning with the runway when they're coming in. Now we know recently that they've been changing those, but let's just have a look at what is taking place then with regards to the Livingston and Penn data. So here is that graph which shows a very similar pattern to the one that we was just looking at. And what Livingston and Penn noticed, first of all, that over a period of time of observing the sun, they noticed there was a reduction in sunspot numbers, and the correlation of their research showed that 2 things was happening. The surface of the sun was increasing in heat, and also the sunspot numbers were decreasing. And it was found that an increase in heat, I think by off the top of my head 45k per year, led to a decrease by around 77 gauges or something around those. It's not important. What's important is that as the surface of the sun increases, the magnetic ability for sunspots to form decreases. And we can see that by 2015 it will be unlikely that we will get sunspots form after that point, because there is a cut-off point for sunspots to form, and that is, as we can see on the graph, when it gets to around 1500 gauss on the left hand column, and the cut-off point is around 2015. So we've got what is causing the sunspots to drop, and we've also got on the other graph a trend that is predicting the same point. So we've got what is causing it and how it is being, the effects that it is having on there, and we can see that, not only that, if we look at the sunspot observations for the last 400 years, and we go back to the 1650s, which was noted to not have any sunspots during a 50-year or so period of time before it showed any signs of significantly increasing, we can see that the northern hemisphere of the Earth experienced what was known as the Little Ice Age, or the Maunder Minimum. So you may think then, guys, that with an increase in surface temperature, that may result in an increase in irradiance, or total radiation received by the Earth's surface. You might think that if there's an increase in temperature, at least on the sun's surface, that would affect the irradiance or the radiation that we're receiving, but you can quite clearly see from this the intensity of solar radiation reaching Earth has been relatively consistent through the last 2000 years. So it is not the surface temperature of the sun that is affecting or seems to affect climate on the Earth. It is actually the sunspots reducing in numbers. Now, what is the interaction then directly with the Earth and the sunspots that regulates the climate on the Earth? Well, the interaction between the sunspots and climate is a little bit of a dark area, which is still undergoing a lot of work, and how that interacts, how sunspots actually interact. But one thing we can see from this graph is that when we get a reduction in sunspot numbers in the trough on the top part of this graph, we get an increase of cosmic rays. And this is a suggestion. It isn't proven yet that this could be the case, but what we can see is that, as you can see, these peaks on the cosmic ray graph increase, and more so over the most 2 to 3 recent solar cycles. So what we've been getting over the last 3 solar cycles, or 36 years, is an increase in cosmic rays every time we have a low trough in sunspot numbers, or a low amount. So we are seeing something then that could be affecting the climate in favour of cooling it. But how does it do it? Well, if we just look at the heat in terms of electromagnetic infrared radiation, right? Now, I know what people are going to say. Hang on, you've just said here irradiance hasn't altered over the last 2000 years, and radiation must also include the infrared segment. Well, if we just put that aside for a minute and ponder the theory, what could be causing it, what I'm going to suggest is that these cosmic particles, or cosmic rays, are acting as, to give an analogy, a radar jamming field. So when we get a lot more radiation or cosmic rays inbound because of the low sunspot numbers, now that could be due to the heliosphere shrinking, improving the vacuum, or we do know that there's a connection between sunspots, keeping the heliosphere expanded and therefore pushing out these radiation, cosmic rays. So what I'm going to suggest then is that what is happening to the radiation that is emitted off the sun, it is being watered down by the cosmic rays, and therefore the actual amount of heat that we receive on the surface of the Earth is being reduced by the cosmic rays that we're getting during low sunspot numbers. Now, it's a theory, it's not proven, and I don't work with any of the space agencies to, push these out there. I know sometimes, from time to time, we do get people from NASA come over and add a comment or so to some of these videos. I'd welcome their input on this with regards to this. I'm just trying to connect the dots, as to why it affects the climate during a continued period of low sunspots, as we've seen on the graph during the Little Ice Age, or the Maunder Minimum, around the 1650s. So what I'm suggesting is that it could be a relation between the sunspot numbers being low, the heliosphere, which is like a big balloon that our solar system sits in, which is inflated by the sun itself and the production of sunspots. When that reduces or weakens, we get an inbound or more flux of cosmic rays. The cosmic rays then block out solar radiation and possibly causes a cooling of the Earth. Now, there is one other thing that I've mentioned before. If the situation is this, that we are getting more heat from the sun during the period of a time when sunspot numbers are low. Now, I know this contradicts it again, but if we are, then it stands to reason to me that if there is water on the Earth and it receives a higher influx of radiation in the form of heat, then there's going to be more evaporation take place, and this is going to compound in the atmosphere, and it's going to, I would predict that the more water that goes into the atmosphere would end up at some point, it stands to reason to me, in the jet streams, and therefore make them more sluggish, and that would slow them down to the point where they would yonder and fracture at some points. And now that is exactly what we see when we look at some of the satellite data. We can see that these jet streams have changed over recent times, at least from 2007, where it's been more noticeable. And this is the point where the climatologists come in and say, we have seen the weather do something over the last 10 years, which has been an extreme and something they've never witnessed in their entire career, some of them having 40 years in climatology. It could be due to the laying down of more precipitate in those jet streams. And I've got to say this, the more water that goes into the atmosphere could contribute to a unbalancing of the system. We've looked at this before, and it could give a negative feedback or a positive feedback depending on how much is in there. First of all, water is H2O, so it's a trimolecule, and it is one of those greenhouse gases that absorb an amount of radiation itself, and it can also reflect it out. Now, I've also discussed this before, that if we look at densities of gases, water is going to be somewhere above H2O, CO2, which is another trimolecule, and the point is the interaction is going to take place with the H2O model in the atmosphere molecule before it has an opportunity to interact with the CO2. And this is why I say that the these scientists that are saying the more CO2 that we put into the atmosphere stands more of a chance of interacting and creating climate change. Therefore, man possibly is responsible for this climate change, and we're going through global warming. My only argument to that is, if we look at the chart I showed you earlier during the Maunder Minimum, it actually went through a cooling period before 1760, which is when the Great Industrial Revolution began. So we were seeing changes and dramatic changes to climate before the Industrial Revolution began. And the reason why I mention the Industrial Revolution is because they are saying that since the Industrial Revolution took place, we have seen an increase in CO2 from that point in time, and therefore an increase in climate in favour of a warmer climate on the Earth, or global warming as they've been classifying it. But the problem is we've seen dramatic changes before that period of time, and therefore we cannot say that it is CO2 and man that has been responsible for the climate heating. Now, I will also add this. Listen, if you throw thousands and in fact millions of cubic tons of anything into the atmosphere, it is probably going to have an effect at some point. We don't know what the saturation point is of the Earth with regards to CO2. The only thing I will say at this point is that the Earth has a way of managing CO2, and before there was a breathable atmosphere on the Earth, going back millions of years, it was an atmosphere that consisted solely of CO2, and the way in which the Earth scrubbed that CO2 out and as a byproduct put oxygen in there was by the zooplankton life in the sea, that little microscopic sea lives, because they're natural filters of zooplankton, sorry, of CO2. Now, I would have suggested that if from the 1760s we was putting more CO2 into the atmosphere, then the things such as the zooplankton and other biodiversities that take in carbon dioxide, carbon monoxide as part of its normal routine would have also thrived recently from that 1716 onwards. What I'm saying is that it's like, if there's only 3 lions in an area and there's only amount of food for 3 lions to exist, then the population of lions won't exist beyond that area unless more food can sustain more lions. It's a little distraction, but it's an analogy to give you an idea of what would happen. What I'm saying is that if there's more CO2 in the atmosphere, then trees are going to thrive. There is going to be bigger populations of this zooplankton in the seas, unless there is something else that interacts with that, such as it could be the El Nino, which favours less production, or less favourable environments for those things to thrive. Now, we could keep going on and on and on, but the getting back to the point, here, I don't think man is responsible for the climate change at the moment. If we want to go further afield from the solar system, then what was it that started this in the first place, and what was possibly responsible for it during the Maunder minimum period, and what possibly brought us out of that period? Well, there is obviously a connection with the sun and climate. I think most children would say, what makes it a lovely day out there? It's the sun itself. But it's what the sun is doing and what affects the sun during these low sunspot numbered periods, which I have pondered. Again, I have said, as NASA has said recently over the last few years, they said they noted that there was a wave approaching the solar system. Now, could they have been talking about something that was emitted from the centre of the galaxy? And I think and there has been a few other scientists, apologise for not mentioning the name. I know that Camelot mentioned one of them, a solar physicist that came up with this superwave theory, and I like that theory because it seems to make sense, because it adds something that isn't already there in the solar system, or at least isn't there in the quantity which it could be there over the recent years, and that's probably the wave that NASA's talking about. Now, how do these waves exist? Well, in the centre of our galaxy we've got a lot of very old suns, and they're very large suns, and when they what happens is, in a spiral system, you have towards the centre a more condensed area of suns. Now, it stands to reason some of these might be going into the super bulge and exploding, or they might even be colliding. Now, you could see why they would collide, because there's just less distance in that centre for such large masses to exist without collision. Now, what happens when they do collide is we probably get massive supernovae explosions, which do emit large clouds of energy, and they've got to emanate out from the centre of our galaxy up until the point where they reach our position on the spiral arm, at the position where we are now. And that wave of energy will saturate our solar system. Now, I asked the question, is that what NASA was talking about? And is it these waves that affect the sunspot numbers? Now, I say it's an energy increase to a system, and it's got to show up somewhere. Now, I feel it is showing up in a similar manner to what I've suggested could be happening on Earth. Only it affects it differently. With regards to this radar jamming, or this cosmic ray jamming of heat, I think what it does is it nullifies the magnetic ability for the sun to form sunspots, and as a relationship to that, the sun's surface heats, and as a relationship to that, more cosmic rays saturating the plasma field of the Earth perhaps leads to a jamming of heat actually penetrating through to the surface. It's a theory, guys. This is what climatologists are proposing, and other space weather organisations. That's why they are describing it now more so as space weather. I think the influence of weather and climate now emanates from what is taking place within our solar system on a whole. So again, I also feel as the sun is increasing on its surface temperature in heat, this type of radiation is also having an effect on the core of our planet in a way which may increase core temperatures to the point where we get magnetic weakening. Now, the reason why I say that is because we've seen this already happen on the sun. We've seen the increase in temperature lead to a decrease in magnetic ability for sunspots to form, and I say an increase in the core temperature by perhaps a few K. Not sure of how much would need it to be to influence such a large inertia as is in the interior of the Earth, but from experiments conducted myself, as I've shown in previous videos, when you increase heat of a magnetic entity of any sort. We used a magnet in that experiment where we introduced it to the heat, and it lost complete magnetic ability to direct the course of a compass needle. So I see the weakening of the magnetosphere right now being directly related to a core temperature heating, and if we just consider what's happening on a crustal aspect of the Earth, we can see that there has been more earthquakes over the recent 50 years, and also on a greater magnitude we also see that there has been an increase in volcanic activity, which would be degassing due to increased pressure, due to increased core temperature. So it stands to reason that these things are possibly linked in the way I say. And we've also seen, if we just look at the last 20 years, the magnetic pole splitting. And I say splitting because at first we thought, up until recent data that we obtained from the Swarm mission, we thought it was a pole that was migrating over the hemisphere. No, this is a pole splitting, and what we've been tracking is the centre of where it is splitting. And I've shown you in an experiment that when you get two magnets, you start to pull them apart, the compass will remain in between the two magnets until one of those magnets leaves the vicinity and therefore is in a stronger field to attract the compass needle. And that is exactly what we're seeing. So what I promised in this video would be the magnetic declination. Remember, we was talking about why the runways have been renumbered and you know, how it is related to declination. So what I want to show you then, and I want to ask you to just pay more attention to over the more recent years, is the speed in which the magnetic declination changes. So we're talking about the last 20 years on this video that I'm about to run, that I find is more evident of a magnetic pole shift in transition right now. The only other thing I want to say to you guys is it's very easy to overlook things that are in front of your eyes than it is to start pulling you know, trends and data out of things that we, you know, have to go searching for. The reason why I'm saying this is because sometimes people get confused with pole shift news. They think we're talking about the rotational pole and not the dipole of the magnetic poles. But I want to say this: the rotational pole is over the Arctic region, which is the coldest, one of the coldest regions on the Earth, one of the two coldest regions. We've got the Antarctic and the Arctic, and we've got over the Arctic Circle a very cold region. We also have a rotational axis, and we also have a magnetic dipole. I just want to say this to you, right? We have this on the North Pole, and we have these things on the South Pole. And I think you will agree with me that there is a reason for these regions being the coldest, also having the poles on them, and also having rotational axes on them. Now, we haven't seen rotational axes shift at the moment. That's what we've been tracking the sunsets for. But it doesn't mean to say we won't at some point, when the Earth has gone through a magnetic you know, transition, where the poles are in somewhere different, when they reform again. And I believe when they do reform again, we will have a new, not only will we have a new North Pole, but we will have a new Arctic and Antarctic region on the Earth, and we will also have a rotational axis shift. That's right, because I don't think that it is coincident that the rotational axis is over the poles as it is. Now, that's something we can have a look at, I believe, in experiments, as opposed to when I set up a coil rotating and we position the magnet in different positions, because I know that removing the magnet stops the rotation of the coil. So we've got rotation, we've got magnetism, you know, so we can experiment with that, guys. But I really do feel that there is no coincidence in where the rotational axis is right now, that being in the same vicinity of the coldest regions on Earth, and also the regions where the magnetic poles are. What does this mean then if we get a rotational axis shift? Well, it means that some of those stories perhaps in these ancient books such as the Bible with regards to flooding, and also what Plato discusses with regards to you know, Atlantis sinking in one day, could quite possibly be on the cards for the near future. Remember, we are going through a magnetic transition right now on this Earth, and it is picking up speed as the days go on. This thing is getting quicker and quicker. But the thing that I'm talking about, if we get a rotational axis, that what is caused by, you know, the centrifugal force of the planet, what I'm talking about is the oceans bulging around the equator, will shift at that point in time. Some say that the equatorial bulge with relationship to the water is at, on average, a kilometre, 1,000 metres higher than any other sea level across the Earth. You know, that can be checked. I don't know how accurate that figure is, but I do know that there is a larger amount of water bulging at the equatorial regions, and the equatorial regions are in between the North and the South Pole. And if the South Pole changes and we get a rotational axis change, then the distribution of that water is going to shift. So bear that in mind, guys, with possibly some of those planning preparations that you've put up, because we don't know is the honest answer. We have no records of when the Earth went through a magnetic reversal 780,000 years ago. I'm talking about the grand reversal, where we actually get a reversal. That is, the information that we've extrapolated from the Atlantic ridge spreading as the material pushes over the ridge and pushes along. It gives us an accurate representation of when the Earth over millions of years has gone through several reversals. The only other thing I want to put out there, guys, and I know this video is going on a little bit and we still haven't got to the video that I want to show you, is just bear in mind that prior to this reversal that we're witnessing take place right now, the last one was 780,000 years ago, and then before that it was on average for a period of time around every 250,000 years. Why did it take 780,000 years this time round? Is something slowing down with the planet, and could it be already at the point where what has taken place on Mars could be taking place on Earth right now? What I'm saying is that Mars, by the way, used to have poles. It used to have Arctic regions on there. There was water on Mars. Some of these scientists say that it had an atmosphere and it had a magnetic dipole, which it hasn't got right now. We know that there is some traces of water beneath the surface on Mars, and we know that it did have a magnetic pole at that time. But for a vast amount of time it has not. What I'm saying to you guys is the planet gearing up to be uninhabitable. If it is in the nature of solar systems perhaps to for a period of time have life and have life evolve on it, and then life ceases because of the conditions no longer favour it. Just throwing that thought out there, guys, because a lot of people take for granted what we do have on this planet right now, and when you put that in context with just what's taking place in the news right now, with a gearing up to a third world war with Russia, that could destroy us anyhow. Well, it could already be in the cards for ourselves to be no longer on an inhabitable planet Earth. You would think that if you knew tomorrow was the last day, that you would make the most of today. If you knew that the next 1,000 years were the last, that you would try and make the next 1,000 years the most enjoyable years for the future generations that will inevitably at one point experience a planet that no longer sustains life. And with that, guys, I think I better get on with this video with the declination, so I'll go and dig that out. I'll add it to this video and you can watch it. So I'll let the the program run a few times for you. You can stop it at any point you want. I'll just point out that we've got a lovely equatorial view of the whole of the planet, and also we've got an Arctic region and an Antarctic region. But it's those bending and winding of those lines that actually makes the compass point off to the North Pole. But as you can see that they do bend and curve off. and it's these lines that have caused the runways to redesignate new headings for the pilots to come back in on their approach to. But you'll see now how fast they start to change from around 2000. You have to wait for the cycle to begin again. Again, I don't know how accurate it would have been from the 1600s. I think they'd be going on merchant shipping data to obtain the declination at that point, because it is an important thing to know your declination with regards to navigation. But as we start to come up through the 1900s now, we'll start to see the yondering of those lines occur more frequently, and we see, if we look over the Arctic region the next time it comes round, the field lines separating, so that we get to, let's see if I can forward it to that point. Right, these are the bows that I'm talking about. It's like a figure of 8, and we can see them tighten up to the point where they snap in. So there you go, guys. We were at the end of the video. It has gone on a little bit longer than what I expected, so I'll try not to keep you much longer than what I will. This weekend I'll be going away for a week, so if you don't hear from me within the next week or so, it's because I've gone away for the week with the family. We're going to do a bit of fishing and walking along the coastline and things like that, and just enjoying some quality family time. There's a link down below, guys. I know it's not always evident, but there is a lot of work that goes into the research, and the foundation of this channel is the magnetic pole migration with regards to the dipoles, as well as it could also be a rotational shift, but that is the foundation of what this channel does. But we do look at other things. I did promise that we could have by now got that Newman motor, the reverse Newman motor, where we spin the coils as opposed to the magnets in the centre. That's another project that I want to get sorted out. That creaking, by the way, is this dodgy chair that I'm on. But that's a sidetrack. Anyhow, guys, I'm going to say what I usually do: be safe, be prepared, and well, I wanted to say something about what we're all witnessing at the moment take place in the world with Iraq, Gaza, and everywhere else. But on top of it all, it really is too much, isn't it, sometimes? So link down there, guys, if you want to support the channel. Even if you just want to buy the host of the channel, myself, a beer on holiday, now's a good opportunity to do so, and enjoy the rest of your day. And as always, bye for now.